Hello everyone. In this video lecture we're going to learn about angle relationships and similar triangles. Some of the topics we'll learn about include vertical angles, angles formed by a transversal through parallel lines, the sum of interior angles of a triangle, types of triangles, and similar triangles. As we work with angles, one of the first type of pairs of angles that we come up with which are special are vertical angles. When two non-parallel lines, meaning a pair of lines such as the one depicted here that have a point of intersection, that's what we mean by non-parallel lines, because two parallel lines in a plane do not ever intersect, so they have no point of intersection. Then four angles are formed as depicted here. We've called them angle 1, angle 2, angle 3, and angle 4. And we can easily show that angle 1 and angle 2 are congruent, meaning they have the same measure. And we can also say the same about angles 3 and 4. In other words, they not only appear to be equal 1 and 2 and then 3 and 4, but they in fact are. Here's a real quick proof of the fact that the measure of angle 1 equals the measure of angle 2. Notice that we recognize from our work in the previous video that angle 1 and angle 3 are special. They're supplementary. They're also adjacent. So we know that the measure of angle 1 plus the measure of angle 3 equals 180 degrees. We also can see that the exact same holds for angles 3 and 2, right? The measure of angle 3 and measure of angle 2 also add up to 180 because those two are also adjacent supplementary angles. So we also have the measure of angle 3 plus the measure of angle 2 equal 180 degrees, correct? So now notice, since both of these expressions are equal to 180, that means they're equal to one another. So now we can say that the measure of angle 1 plus the measure of angle 3 is equal to the measure of angle 3 plus the measure of angle 2. Now notice we can subtract the measure of angle 3 from both sides. Therefore, it basically zeroes out, and we end up with the measure of angle 1 is equal to the measure of angle 2. So that's just a quick proof to show you that these two angles are indeed congruent and have the same measure. You can do a very similar proof for to show that angle 3 is also congruent to angle 4 and that their measures are equal. So remember, vertical angles are congruent. Here we're asked to find the measure of these two angles. Of course, we know that we really only need to find one of them because the other one is going to be the same. But we'll find both just to be on the safe side. Now, we do know that these two expressions must be equal because these are a pair of vertical angles. So we get an equation 2x plus 60 equals 8x plus 6. Now if we move the x's to the right side, we get 8x minus 2x, and we'll go ahead and move the constants to the left side, so we get that. So we get 54 is equal to 6x. So dividing both sides by 6, we can see that x must be equal to 9. Now, we don't want to stop there because that's not what we were asked to find. We were asked to find the measure of these two angles, right? So we're going to go ahead and plug in to those expressions the value of x that we just found. Now, as I said, one should be enough, but it's a good thing to plug it into both to make sure that we haven't made some kind of an arithmetic error. As you know, both should end up being the same once we substitute 9 for x. 2 times 9 is 18. 18 plus 60 is 78. And 8 times 9 is 72 plus 6 also gives us 78. So the measure of the marked angles for both angles is 78 degrees. Just like that. So that's just a quick application of the fact that vertical angles are congruent. All right, now we get to parallel lines and transversals. As you know, two distinct lines in the same plane that have the same slope will never intersect, and they're called parallel lines. Now, the distinctness is basically going to play a role here, because otherwise we wouldn't be able to really discuss a transversal in a meaningful manner. So if we have two distinct parallel lines, otherwise you can know that if you have two lines that are the same, they're also going to be parallel, right? If we're talking about basically different copies of the same kind of line with the same equation. But here we're going to be looking only at distinct lines, meaning different lines. Remember, distinct in mathematics means different. And we're going to see what happens when a line intersects both of them, all right? So that kind of a line which intersects a pair of parallel lines is called a transversal. And what happens is 8 angles are formed. Let's take a look at the situation. As they say, a picture is worth 1,000 words. Here it is. So here we have a pair of parallel lines right here in blue, and we have a transversal here in maroon or red, however you can see that. And that's what we call a transversal. Notice we end up with 1, 2, 3, 4, 5, 6, 7, 8 angles. Now, as it turns out, we have interesting groupings here. Any pair of, if you pick any pair of those 8 angles, they're either going to be congruent or supplementary. There's no other possible case. All right, so in fact, as you will see, the way it turns out is be careful that you basically base your understanding on the actual fact, not just visual claims. But if the slope is large enough, you can see they're going to look either congruent, like these 1 and 4, 2 and 3, or they're going to look supplementary. So the fact is, if they look congruent, they in fact are, and if they look supplementary, they are supplementary as well. So the proof of all those statements are something really handled in a geometry class, not very difficult at all. But here are the facts you need to know. 1 and 2, they do add up to 180. That's clear. We know that those are adjacent supplementary angles. Same with 3 and 4. Same with 5 and 6, and of course with 7 and 8. Now, what may be less obvious is the fact that 1 and 7 are also supplementary, as are 2 and 8, right? Now, visually it makes sense, right? It looks like they are, but again, it can be easily shown that they in fact are. And 3 and 5 are also supplementary, as are 4 and 6. Now, 3 and 5, these are called same side interior angles. Interior meaning within the interior region of between these two parallel lines. 1 and 7 are called same side exterior angles. 4 and 6 would again be same side interior angles. 2 and 8 would be same side exterior angles, right? So we can see that same side interior angles as well as same side exterior angles are always going to be supplementary. That means their measures are going to add up to 180. Now, as far as which angles are equal, we know that 1 is equal to 4, of course. Angle 1 and angle 4 are congruent. When we say equal, we mean their measures are equal. Sometimes we speak loosely, but you should always know exactly what we mean here. Notice that 5 and 8 are also congruent for the same reason. They're vertical angles. Now it also turns out that 4 and 5 are also congruent. You can see they look congruent, but of course we don't just go by the looks, we go by the positioning. These two are called alternate because they're on different sides of the transversal, and interior because they're in the region between the two parallel lines. So alternate interior angles are congruent. Notice 3 and 6 are also alternate interior angles, so those are congruent as well. So here are the groups of congruent angles: 1, 4, 5, and 8. They're all congruent. That means their measures are all the same. Also 2, 3, 6, and 7. All right, so remember that these angles here, 3 and 6, are called alternate interior angles. 4 and 5 are called alternate interior angles as well. All right, now 2 and 7 are called alternate exterior angles, right? Remember, those are also congruent. So alternate interior angles as well as alternate exterior angles are congruent. Okay, the only name remaining we haven't discussed are what do we call an angle like a pairing like 1 and 5, right? Notice they're in the same corresponding position to the left of the transversal and above the line that is one of the parallel lines, right? So notice 5 as well, to the left of the transversal above this line, right? So we call them corresponding angles. All right, now it turns out that corresponding angles, as you can see, 1 and 5, they're also congruent, right? So the other pairs of corresponding angles would be 2 and 6, right? 3 and 7 are corresponding angles. 4 and 8 are corresponding angles. Notice all the cases of the corresponding angles, they're congruent. Alternate interior as well as alternate exterior angles are always going to be congruent. Same side interior or same side exterior angle pairs are always going to be supplementary. So there are lots of angles here, but this is very easy to absorb and remember. So make sure you understand all the terminology because we'll be using it. You don't want to have to go back and revisit the definitions every time, and also make sure you understand all the relationships comfortably. Pause the page, get this done, then move forward. All right, here we're going to find the measure of the marked angles, right? In other words, we want to find the measure of 1, 2, 3, and 4, right? Now notice that we know that the measure of angle 1 and measure of angle 2 are going to be adding, supplementary, meaning once we add the measures, we should get 180. Now, more interesting, notice that angle 1 and angle 4 are alternate, right, exterior angles. Now, we know that alternate exterior angles as well as alternate interior angles are congruent, right? So we have an equation here we can start with. We have 3x plus 2 equals 5x minus 40. So moving the x's to the right side, we get 5x minus 3x. And moving the constants to the left side, we get 2 plus 40. So we get 42 equals 2x. So x equals 21. So let's see what 3x plus 2 becomes. So we get 3 times 21 plus 2. So that's 63 plus 2, which is 65. So we know that this angle here is 65 degrees. Now we also know that the measure of angle 1 plus the measure of angle 2 equals 180 degrees, right? So 65 degrees we can be substitute for the measure of angle 1 plus the measure of angle 2 equals 180 degrees. So we end up with the measure of angle 2 being 180 degrees minus 65 degrees. So we can just take care of that. So we have 180. You can of course do that in your head if you like, but just to be on the safe side, we'll go ahead and utilize it. We can always use technology for these simple arithmetic type situations. And here we get 115. All right, so now we know that angle 2 is 115 degrees, right? So let's keep track of them. So we know that measure of angle 1 is 65 degrees. Measure of angle 2 is 115 degrees. Notice that we know that angle 1 and angle 3 are congruent because those are vertical angles, right? So we have measure of angle 3 is also going to be 65 degrees. And the only one we need is 4. And remember, 4 is going to be the same as 1 because of the fact that they're alternate exterior angles. So the measure of angle 4 will also be 65 degrees. And there we have it. So make sure you understand that before we proceed. All right, next we want to revisit Triangle Sum Theorem, which basically says that the sum of the interior angles of any triangle is going to be 180 degrees. Again, this is the fact that's proven in a geometry class, but we will be utilizing it, so we need to know it. And notice that because there's no extension here of these sides, there's no ambiguity. We can just go ahead and call that angle A, call that angle B, and call that angle C. But we know the sum of their measures will be 180 degrees, regardless of what the triangle looks like. Here's a quick application. We want to find the measure of the 3 angles, basically the interior angles of this triangle. Now we know that these 3 expressions are going to need to add up to 180. So that's the equation we start with. So x plus 20 plus 180 minus 3x all should add up to 180. Now, of course, because we have 180 on both sides, we can go ahead and cross them out, leaving us a 0 on the right? If there is nothing left, we can usually leave it blank, but if 0 is going to play a role, we need to write it, otherwise it could be forgotten. So now combining the x terms on the left side, we get 1x plus 1x is 2x minus 3x is negative x plus 20 equals 0, correct? So moving negative x to the other side, we quickly get 20 equals x, okay? So now that we have that, we can get the values of all 3 angles. So we have x plus 20, and 180 minus 3x. I like to organize them in the form of a table. So now x we know is 20, so x plus 20 is going to be 20 plus 20, so that's 40. 180 minus 3 times 20, right? 3 times 20 is 60 for this expression here. So 180 minus 60, that's 120, right? So we know that the angles are going to be 20 degrees. X plus 20 is going to be 40 degrees, and the large angle here is going to be 120 degrees. Notice that it is not drawn to scale, right? So one quick check that we can go through is just add those 3 up, make sure that we get 180. Do we? Notice 120 plus 40 is 160 plus 20 is 180, so we should be in good shape. The reason, of course, I say it's not drawn to scale because this certainly does not look like a 120-degree angle, right? But you always go with the facts, not with the appearances, because your shapes may not be drawn to scale. All right, so here's another application of this fact that the sum of the interior angles of a triangle is 180. Now notice that we have two of the interior angles, this one and that one, but we don't have this one. We have this exterior angle of the triangle right here. So what we can do very quickly is we can go ahead and just call this one y degrees, right? As far as the measure is concerned, let's say it's y degrees. Now we know that y degrees plus 6x minus 38. Let's go ahead and leave out the degrees for simplicity. We know that we're dealing with degrees, so equals 180, right? As far as pure numerical values are concerned, right? Because these two are supplementary angles, right? They're adjacent supplementary. So if you solve this for y, you get 180 plus 38 minus 6x, right? So we get y equals 218 minus 6x. So now we know what can go in here, right? We know that the angle there is 218 minus 6x degrees, right? All right, so now we can go ahead and utilize the triangle sum theorem now that we know all three interior angle measures. So we know that we just want to make sure that we use 218 minus 6x for this angle, not that expression, 6x minus 38. So we have 2x plus 2 plus 3x minus 14 plus 218 minus 6x should all add up to 180. Combining the x terms on the left side will give us 2x plus 3x, which is 5x minus 6x, that's negative x. Combining the constants will give us 2 minus 14, which is negative 12, plus 218 should give us positive 206 equals 180. Now we move the negative x to the right side to quickly turn it into positive x. In other words, add x to both sides. And then we'll subtract 180 from both sides. That's going to take the 180 to the left side and make it negative. So we end up with x equals 26. Now we're ready to go ahead and find all three sides of the triangle. Now that we have x, just make sure you're using the correct expressions, meaning 2x plus 2, 3x minus 14, and this is where you want to be careful, 218 minus 6x. All right. Now that part we can do quickly on a calculator. So let's bring that up. All right, so we have 2 times 26 plus 2. So 2 times 26 plus 2. So we get 54 for that angle. And then we have 3 times 26 minus 14. So that's 64. And then 218 minus 6 times 26, which gives us 62. So one very quick way of checking to make sure we haven't made any arithmetic errors is to go ahead and just add those. So 54 plus 64 plus 62. And I'm sure you know what we should happen as soon as I hit enter. We should get you said it, 180, and we do. Okay, so that's how we handle a problem like that. Again, make sure you can do this on your own, and then we'll proceed. Anytime we do a problem, if you already think you should be able to do it without watching any of my work, then try to get it on your own. That's the best way to go about it. If you need a little guidance, you can watch what I do and then just copy the problem without any of the answers or without looking at any of the work. Make sure you can go through the process smoothly on your own. Next, we want to talk about the types of triangles that we will encounter in this class and beyond. The first type we'll look at are acute triangles. An acute triangle is one for which all three interior angles are acute. And remember what that means. That means they have measures between 0 degrees and 90 degrees. Notice that all three of those angles are somewhere between 0 and 90 degrees. A right triangle is a triangle that has one angle measuring 90 degrees. Now, as you know, of course, it's impossible to have more than one angle with measure 90 degrees, right? Think about why that would be true for a minute before you listen to the rest of the video. All right, so I hope you realize that if you have more than one 90-degree angle, let's say these two angles were 90 degrees. That means you have 90 plus 90, 180. This one is, of course, going to be some positive measure, right? So that means we would contradict the Triangle Sum Theorem because the sum of the interior angles would be more than 180. So that's why it's impossible to have more than one right angle. But as long as you have that one right angle, the triangle is called the right triangle. Obtuse triangles are any triangle that have one obtuse angle. Again, obtuse, of course, you know, is an angle whose measure is greater than 90 degrees. And for a very similar reason as what we stated here, there's no way to have more than one obtuse angle. So all you need to have an obtuse triangle is just one angle whose measure is greater than 90, and of course less than 180, right? We didn't write that, but that's obvious here. Now, equilateral triangles, right, are triangles for which all three sides are congruent. Now, let's see if you remember some geometry. Does that mean that all three angles are congruent as well? As it turns out, yes. So not only are all three sides congruent, but the three angles which add up to 180 are congruent, right? So if we were to call them x degrees each, we would get x plus x plus x should equal to 180. So 3x equals 180. So x equals what? 60. So for an equilateral triangle, the measure of each angle is going to be 60 degrees. An isosceles triangle is a triangle with two sides that are congruent, right? Exactly two sides. So notice that the angles opposite those two sides will be congruent, but not that one. Now, to be isosceles, you really need at least two sides that are congruent. So it would not be, you know, this is also, and in other words, an equilateral triangle is also considered isosceles because it does have two congruent sides, but it's a special isosceles triangle because it's not just two of its sides that are congruent, but all three. So a truly isosceles triangle having just two congruent sides will have the angles opposite those sides congruent, but not the third one, right? As long as this side has a different length from those two, right? Now, a scalene triangle is one which is, you know, just very average, nothing special about it. No two sides have the same length, and of course, consequently, no two angles would have the same measure either, right? All sides have different lengths and all angles have different measures. So these are the types of triangles that we're going to be encountering. One group of triangles that are going to play an important role in our study are similar triangles. Similar triangles are triangles with congruent corresponding angles. such as A and D, B and E, and C and F, and proportional corresponding sides. Now, notice that when you write the similarity statement, it's very important that you put the corresponding letters from each triangle in the correct position. So remember, A goes with D, B goes with E, see, B goes with E, and C goes with F. So they're in the correct corresponding position. Angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. So when we say the sides are proportional, we mean corresponding sides. Notice that, for example, what's opposite the triple marked angle? AB. In this triangle, what's opposite the triple marked angle? DE. Again, in this triangle, what's opposite the single mark angle? BC, right? And in this triangle, EF. And that's going to be the same as the ratio of AC, which is opposite the double mark in the left triangle, and DF in the right triangle. Now, I mean the triangle on the right, of course, not a right triangle. All right, now notice that similar triangles are just that. They look similar, right? They just have different sizes, possibly. There's no problem if the sizes are the same as well, but at the very least, they should have congruent corresponding angles, which is going to force this outcome to occur as well. The sides are going to end up being proportional, the corresponding sides. Now be careful that if you have AB from this triangle on the top in the first ratio, that you put all others, these other two sides, also from this triangle on the top, and for this triangle on the bottom. You could have done it the opposite way. You could have started with DE over AB, then you would have said EF over BC and DF over AC. That would have been correct too. So in other words, we could also have said DE over AB equals EF over BC, which is equal to DF over AC, correct? All right, so this very special relationship exists between similar triangles. All right, here we're going to find the unknown angle measures, right? Now we're going to notice the fact that they have the equal marking on these two angles. So of course, Q should be 27 degrees, right? And these two are both right angles, so they're congruent. So that's going to make these two congruent as well, right? So if you actually wanted to write the similarity statement for these two triangles, you could start with triangle ABC is similar to triangle. Now notice A goes with Q, so we would put Q first. B is going to go with P, and C is going to correspond to R. So you would go like so, right? All right, so if we can find B, the measure of angle B, we'll also have the measure of angle P. So that's all we need to do. So we know that the measure of angle B is going to be 180 degrees, take away 90 degrees, also take away 27 degrees. Why? Because all three of those angle measures should add up to 180. So any of them is going to be 180 minus the other two, right? So that's going to be 90 degrees minus 27 degrees, which is 63 degrees. So we have the measure of angle Q. We already had the measure of angle A, so we know that the measure of angle B is 63 degrees, which is the same as the measure of angle P. And of course, C and R are both right angles, so they will both have measures of 90 degrees. All right, that's how you would handle that. All right, here's another similar triangle scenario. What you really want to make sure you do with this kind of a scenario is mark the triangle properly. Notice that these two angles we know are going to be congruent because they are vertical angles, right? And of course these two are congruent because they're right angles, so that's going to force these two to be congruent as well, right? Because each of them is going to be 180 minus the sum of two congruent angles. So therefore if I use a double mark here, we use a double mark here as well, right? So the reason we need to mark the angles properly is because we're going to set up our proportion using those markings. So let's say we start with the side opposite the single mark on this smaller triangle, right, which is 20. Let me go ahead and use my darker color, it's easier to see. So 20 over, now here from this triangle, what's opposite the red, or single mark, right? X. Now I can see that 30 here is opposite the right angle, right? So if I put 30, remember, since 20 was from this triangle, whatever goes on the top here should be from this triangle as well. So 30 over, and what's opposite the right angle in this triangle? 33. So there is the simple proportion that I have to solve in order to find x in this figure. Of course, I have had clever students in the past that were given this problem and they had no idea what to do because they hadn't done the right type of studying, and of course they did this. Here is x, right? Now I think I gave him a point for a good sense of humor, but that was about it. The problem was worth much more than that, so you don't want to try that. All right, so when we say find x, of course we mean find the length of the side marked by x. All right, so remember that that's a simple proportion. Now that's one of those things you'll encounter a lot in trigonometry, a proportion like this. So a little review of algebra will tell us that here, when you do have a statement of equality of two ratios, this is called a proportion in algebra, right? Remember, when you have that, you can cross multiply. So that implies AD is equal to BC. In case you're wondering why that happens, easy. What we're doing is we're just multiplying both sides by the common denominator of both sides, which is BD. See? Now B cancels B here and D cancels D here. So you get what? So you get AD equals BC. But in general, whenever you encounter a proportion, the fastest way to a solution is to cross multiply. So you get 30x equals 20 times 33. So now we're going to divide both sides by 30. Notice I didn't multiply the 20 and the 33 because then it'll make it easier for me to simplify the right side. Watch. Notice that the 30s cancel here, right? So we just get 1x, which is x. On the right side, notice that 10 goes into 20 twice, into 30 3 times. But I notice that I can also cross cancel the 3 and the 33, right? 3 goes into 3 once, into 33 11 times, right? So now I notice that I end up with x equals 2 times 11, which is 22. So there we have it, okay? Just be careful to mark your triangles properly. Then you just set up your ratios. Be careful, if this comes from this triangle, then this one on the top here should come from this triangle as well, and both of those should be from the other triangle. All right, make sure you can handle that, and we'll proceed. All right, here's our last example for the day, and in this situation we're going to come up with the figure on our own. We have a tree that casts a shadow which is 36 feet long, and at the same time the shadow cast by a vertical 8-foot pole is 12 feet long. We want to find the height of the tree. So let's go ahead and see if we can draw this scenario. So we have a tree. Now I'm not a very good artist, so you'll have to forgive me here, which is casting a shadow, right, which is 36 feet long, and at the same time we have a 8-foot pole which we can put down like this, casting a 12-foot long shadow. So we know that, let me move this like this, so we know that this is this here is 36 feet, right? Again, not drawn to scale. That part is 12 feet, right? And we want to know the height of the tree, so this h here is our unknown, like that. So now what we're going to do is we're going to realize that these two triangles, first of all, they're right triangles, right? Let's see if I can bring back my screen. Okay, notice that they are right triangles, right? And they share this angle, so they have one pair of congruent angles here, one pair right there, which they share. So that means these two must be congruent as well, right? Or you can think of it as the fact that these two lines are parallel and these are corresponding angles. Either way that you think about it, here we have two similar triangles, right? So we do know that the length of the pole is 8, right? So 8 feet. So now we're going to set up our proportion. So we're going to say h is to 8. Now remember, h is coming from the large triangle, right? So what goes on the top here is going to be another side from the large triangle. So we'll want 36 over this one, which is how much? 12. Notice if I split those two triangles up, it might make more sense to you. Look, we have a triangle like that, and we have one like that, right? This is what we're trying to find. This is 8, this is 12, this is 36. Do you see it now? H is to 8 as 36 is to 12. All right, so now you notice we have a proportion again, so we can cross multiply. So we get 12h equals 8 times 36. We're going to divide both sides by 12, and here these will cancel out, so we know 12 goes into 36 3 times, so we get h equals 24, and that's it. So the height of the tree is 24 feet. Whenever you're solving a word problem, you want to give your answer in the proper format. They ask you in the form of a question, give them an answer with words. Make sure your final answer has all the proper units in it, and you should be in great shape. Okay? And that should do it for us for this lecture. So make sure that you understand all the topics, then do the homework, and I'll see you at the next lecture.